This is kind of a continuation of our second learning objective, where we are looking at sugar terms. Now, one of the important things about terminology as it relates to sugar is to identify something that makes them all unique from one another. So, if we look at this same group of sugars that we were looking at on the previous slide, one of the things that I want you to notice is that if you look at glucose, ribose, and glyceraldehyde, these are all monosaccharides. They all have a common empirical formula. Their molecular formulas differ from one another. Now, if you look at the formula for glucose, it has six carbons. Ribose has five, and glyceraldehyde has three carbons. Now, these are all monosaccharides, and we have a terminology that we can use for that. We can indicate the number of carbons that are in a monosaccharide using prefixes like tri, tetra, penta, hex, hepta, octa. Now, most commonly, when it comes to a biologically relevant sugar, we're talking about hex or six carbon molecules. Now, with that said, we use a suffix O, S, E for each of these. So if we were talking about a six carbon sugar, saying that, well, it has six carbons and it is a sugar, which is the case when we compare glucose and fructose and those two to galactose. What we'll know about those sugars is that they all have six carbons, they are all sugars, and they are all examples of hexoses. So if I gave you this chart and I said, which of the following is a hexose? I would want you to say, well, the carbons or the sugars with six carbons. Which one of these is a pentose? Well, on this list, only ribose is a pentose. Now, glucose, fructose, ribose, galactose, and glyceraldehyde are common names. These five common names are the lone common names that I want you to be familiar with. The reason for that is they're most biologically relevant, and we're going to look at each one of these a little bit more than we'll look at other sugars. So the OSE suffix and your prefix is going to give you a good bit of information about the makeup of a sugar. Now, another part of understanding sugars is to know the difference between an aldose and a ketose. An aldose has an aldehyde functional group, whereas a ketose has a ketone functional group. Now, these terms can be put together. For example, a six carbon ketose. So that means it is a sugar with six carbons and has a ketone functional group. That would be a keto, E, T, O. So there's our information about our functional group. Then hex, os. So if you were to see this word, what I'd want you to do is kind of start from the end and say, okay, well, OSE, it's a sugar. Hex, it's a sugar with six carbons. Keto, it's a six carbon sugar with a ketone functional group. Same thing goes for aldotetros. You can decipher a little piece of information from all of these names. Now, this is an example of an aldose. Now, I'll give you a moment and answer the question, how many carbons does this have? One, two, three. So this is an example of an aldotriose. Whenever you're thinking, okay, well, what does an aldose look like or an aldehyde? Remember, an aldehyde has a carbon with a single bond to another atom down here, or an R group, you could say. It has a aldehyde, primarily what you should be looking for is a double bonded oxygen and a single bonded hydrogen. That's a hallmark of an aldehyde. So now, if we look at this molecule, this carbon right here, or this functional group right here, is an aldehyde. So we've got an aldehyde here. This is a carbon, two, three, and four. This is a aldotetros. So four carbons in an aldehyde functional group. Now, one thing that I want you to remember back from organic chemistry is priorities and numbering of carbons. This is carbon number one, two, three, and four. This aldehyde functional group gets priority in terms of its lowest possible number. So that's one thing that we want to keep in mind. Next up, we have a carbon number one with an aldehyde functional group, carbon number two, three, four, and five. So this is an aldopentose. And then last but not least, an aldopexose. So an aldehyde and six carbons. So if you know that and can be able to decipher that, that's going to put you in a good place. I always like to start with aldoses and aldehyde functional groups because they're a little bit simpler. Now, with that said, this is where we're going to wrap this learning objective.